Good afternoon and a warm welcome to our presentation on mapping forced academic migration, an ongoing project at the University of Bern, Switzerland. I will start by giving an introduction in our topic, our research questions, data and software, and then Sinja Clavadetscher and Stefanie Salvisberg will continue by putting some meat on the bone and presenting a first example and show how data analysis and visualization look like. In April 33, the law for the restoration of the civil service was passed in Germany. In the course of the following month, over 3,000 academics lost their jobs. Most of them were Jewish. Roughly 50% of them went into exile, which caused likely the largest academic migration in history. This vast migration is a topic of our project. Our research is driven by three main objectives. We ask in which ways the academic network changes due to the expulsion of academics from German universities and later other countries during the 1930s and 40s in respect to geographical, institutional and personal changes. We are interested in the impact of this forced migration on individual academic biographies, and we study the position of Swiss universities in the changing academic landscape. It is our goal to visualize these three main research questions I have just formulated. So it has to be our long-term goal to store the data of all scientists who lost their jobs during the Nazi era in order to illustrate the global academic migration, but also in order to visualize shifts in global academic networks, shifts in scientific centers, the transfer of knowledge, and also the changes of disciplines. We also aim to store all data of scientists at Swiss universities, not only the ones who migrated to the country, but also the ones who are already there. So to really focus on Switzerland and see and depict changes within the Swiss academic landscape. Can we, for instance, see a nationalization or an internationalization of the academic body? Who are the people who came? How did they change the fields, their academic fields? And then furthermore, we also store the data of rescue organizations in order to study the role of academic help organizations in this forced academic migration. This is also to see the role of personal networks vis-à-vis institutionalized networks. So as you can see, we do grasp this term mapping quite broadly. In a nutshell, we are interested in the interplay between structures, institutes and knowledge across time and space, and to bring this on a map. Another question is, how do we bring this on a map? We decided to work with NodeCode, a web-based software developed for the humanities, which allowed us to build our data model based on our research questions. NodeCode offers relational modes of analysis with spatial and chronological forms of contextualizations. We use it for data storage and organization, but mainly to analyze our data in many different ways and to finally also visualize the data. And you will see examples a bit later. A quick word on our data. We store the personal data of refugee scholars. First and foremost, their names, their fields, their academic biographies. It's also always linked with a GND number, so we know we have the right person. And from there, we do also store different information concerning relationships to institutions, but also to other people, to really depict also networks and movements from and to institutions. Our data is collected mainly from archival sources, but also from published and unpublished lists of refugee scholars. To make all of this a bit more concrete, we prepared some visualizations on the fate of German mathematics and mathematicians. Since around 1900, the University of Göttingen was the worldwide center of research in this field, and this changed drastically after April 33 because most of the researchers were Jewish and therefore expelled. So what we can see is obviously a migration of people, this we can expect, but the data also shows a transfer of knowledge, as you can see in this slide, and shifts in academic centers. I would now like to give the word to Sinja, who takes it from here.
Following Stefanie's explanations, I would like to map the movements of these mathematicians with a focus on their career. On this map, you can see the different career steps, such as the place where one earned a degree or got an appointment between 1925 and 1950. I'm going to split up the period in smaller time slots and to show you the change in position of the University of Göttingen during time. Until 1932, many mathematicians passed through Göttingen on their career path. This is shown by the arrows and this blue point, which is Göttingen. As mentioned by Stefanie, many of the mathematicians were Jewish or had a non-national socialist background. Therefore, it is not surprising that when it comes to 1933, the year the Nuremberg laws were passed, the career points and hence the people in Göttingen diminish, and they went to the US, Great Britain, even to Switzerland. So the visualization underlines our hypothesis that as a result of the leaving mathematicians, Göttingen got less important. At the same time, this overview not only illustrates or proves already available information, but also raises new questions and gives insights for further research. I'm just going to talk about two examples. First of all, as we observed briefly what happened after 1933, one path does not fit the overall pattern. It is this case from the mathematician's name, which went to Göttingen in mid-1936, and later on he went also to Switzerland. This case opens a new field of questions and points out that it is also of importance to give attention to what happened in Göttingen and in Germany after the exodus. Secondly, the map showed or supported our hypothesis that many mathematicians left due to anti-Semitic laws. As our team aims to store the reason for termination of every professional position, it is possible to make comparisons on a larger scale, such as between universities or even countries. This visualization here shows the grouped or thematically grouped reasons for terminations of mathematicians. As we see, the red and orange points, they confirm that the trend in Göttingen is true for a large number of mathematicians throughout Germany. And as we stored also the information of other countries, other universities, we can even compare their reasons in Germany with the reasons in Switzerland over time. I already mentioned Switzerland, and before Stefanie will talk about it in a second, I hope I showed you briefly that visualizations of historical findings are more than illustrations or proving instruments. Well used, they are research tools themselves.
As just mentioned, the focus of the last part of the presentation is on Switzerland as a location in the transnational network of science, respectively on the appointment policy of Swiss universities, the influence and handling of academic migration. The following example highlights the development of full professors for mathematics in Switzerland and aims to show the possibilities of a chronological visualization. This chronological visualization shows the total number of full professors of mathematics at Swiss universities, sorted by year and subdivided by Swiss and non-Swiss. It can be seen that the majority of professors in the period under consideration were Swiss. The number of foreign professors reached a peak in 1933. Looking at the visualization, the question arises whether the increase of foreign mathematicians in 1933 was due to the appointment of a scientist dismissed in Germany. If we now move away from this overview to the concrete personal data, we see that this is not the case. Anton Huber, who was hired or rather promoted in 1933, had already worked at the University of Fribourg in Switzerland. In 1938, after the Anschluss of Austria, he moved to the University of Vienna. Besides that, we can also see that he joined the NSDAP in 1935. The decrease in the number of foreign mathematicians between 1936 and 1941, which can be seen on the graph, is therefore due to the change of position mentioned above. Another reason was the immigration of the Jewish mathematician George Polya, who had been working in Switzerland since the First World War. Due to political developments in Europe, he left Switzerland for the US, where he continued to teach at Stanford University until the 1950s. Chronological visualization, as shown, is suitable for presenting large amounts of data and to make developments visible. This, in turn, makes it possible to examine the data more deeply and to place it in different contexts. This yields unexpected results that would otherwise have remained undiscovered, but also helps, as Sinja mentioned earlier, to check hypotheses and to identify connections between projects and research interests. The case of Rolf van Linne, which Sinja mentioned earlier, is an example of that. Not only is his case interesting with regard to the events in Göttingen after 1933, since he was a visiting professor there, replacing mathematicians who were forced to emigrate, but also because he was the first foreign full professor of mathematics to be appointed to Switzerland after the war and after more than 12 years. His appointment is also controversial and worthy of investigation, as he resigned from his position in Finland in 1935 under political pressure because of his membership in an SS volunteer committee, which had no effect on his appointment to Switzerland. How this example of mathematicians is to be located in the appointment policy of Swiss universities can only be answered once all the necessary data have been stored. It will then also be possible to put Switzerland in an international comparison. With these words, I come to the end of our presentation and thank you very much on behalf of our team for your attention. We look forward to questions and suggestions in the discussion round that will follow later.